Hey everyone, and welcome to this Masterclass Explainer. Think of me today not just as your host, but as a lead cognitive science researcher, and I am here to guide you through the absolute foundational concepts of our field. If you've got an exam coming up, well, you are in exactly the right place. We're going to lock down the core research methods and the 12 essential domains of cognitive psychology. By the end of this, you are going to have a rock-solid conceptual map for your studies. So, let's get into it. I want you to start by just pondering this really fundamental question. How exactly do we measure a thought? Seriously, think about it. It is the ultimate puzzle. Cognitive psychology is entirely dedicated to the science of taking the invisible, hidden workings of the human mind and turning them into something observable, measurable, and understandable. We are essentially hunting for the underlying architecture of human intelligence. Okay, let's dive into this. Here is the agenda for our review session today. We're going to hit the why, the goals of research, and the how, our research methods. Then we'll break down the 12 domains of cognitive psychology into 3 chunks: processing inputs, storing knowledge, and complex thought. Go ahead and jot this structure down right now. It's really going to help organize your notes. All right, let's kick things off with Section 1, the why, goals of research, moving from observation to inference. Before we can even begin to look at the brain, we really have to understand our mission here. We are trying to move from what we can directly observe to what we can safely infer. And there's a very specific, proven path for making that leap. We start with data gathering and data analysis, which fuels our theory development. From those theories, we formulate hypotheses, we test those hypotheses, and finally, we look for an application. As researchers, this is the exact playbook for taking a theoretical concept out of a highly controlled lab setting and applying it to the messy real world. You definitely need to know this sequence. Moving right along to Section 2, the how, research methods. Think of this as the cognitive researcher's toolkit. We know our goals, but how do we actually get the work done? Well, first up on our toolkit, experiments. Now listen, if you're taking notes, you will absolutely want to remember the distinction between these two variables. The independent variable is the treatment. It's the thing that we as the experimenters strictly manipulate and control. On the flip side, the dependent variable is the outcome that we measure. Grasping this specific cause and effect relationship is a highly testable concept. Why? Because exerting rigorous control over these variables is quite literally the only way we researchers can infer probable causality. What's really fascinating here is how our different methods actually tag team to give us the full picture. So while experiments in controlled labs test our hypotheses to infer causality, qualitative methods like case studies or naturalistic observation give us these richly textured accounts that are just brilliant for formulating new hypotheses in the first place. Then we have psychobiological research, which uses brain imaging to map cognitive performance directly to actual cerebral events. And finally, computer simulations. This is where we literally program machines to imitate human functions or model the entire cognitive architecture of the mind. And that brings us to Section 3, domains 1 through 4, processing inputs, basically sensing and filtering the world around us. So, cognitive psychology freely draws from 12 principal areas of research. We group these first 4 together because they act as the brain's front door, handling all the incoming environmental stimuli. Let's do a rapid-fire overview. We've got cognitive neuroscience, studying the basic electrochemical processes that support everything from sensation to memory. Then there's perception, the actual detection of sensory signals. But perception alone isn't enough to account for our performance. We also critically need pattern recognition to make sense of complex stimuli, and attention, which acts as a highly selective filter. Let's look a little closer at one of these, and this brilliantly illustrates the magic of cognition: pattern recognition. Just think about the simple act of reading a book. Reading requires you to take an otherwise completely meaningless array of lines and curves printed on a page, organize them into letters and words, and instantly access meaning from your memory. The fact that you perform this incredibly complex neuroanatomical feat in a fraction of a second every single day is honestly nothing short of wondrous. But of course, you can't process everything. Make sure to highlight this crucial concept in your notes. Attention is highly selective because our processing capacity is strictly limited. If too many sensory clues are forced on us, or if we try to process way too many events in our memory simultaneously, we overload, and this overload causes a complete breakdown in performance. I mean, we've all felt that super familiar wave of overwhelm when trying to do way too many things at once, right? That's your limited cognitive capacity hitting a wall. Let's jump to Section 4, domains 5 through 8, storing knowledge, internal states and representations.
We're shifting gears a bit now. Having passed through that front door of processing immediate inputs, we're now exploring how the human brain manages, holds, and represents internal states. So here are the 4 domains in this block: consciousness, memory, representation of knowledge, and imagery. What you really need to take away from this is how seamlessly they all collaborate. For instance, your perception and your memory have to work perfectly in tandem so you can draw facts, like the vocabulary of a language, from your long-term storage in a fleeting second. Plus, you use imagery to form your own internal cognitive maps of your physical environment.
Let's zero in on consciousness. Interestingly, this was once completely dismissed by early behaviorists as being unscientific, but today it is an absolute cornerstone of modern cognitive psychology. It's defined simply as our current awareness. Let me bring this to life for you. Imagine you're studying late. You glance at your watch and see it reads 10:42 p.m. You are conscious of that external signal. But that signal immediately triggers an internal conscious thought: wow, it's getting late, I better finish this chapter and get to bed. That dual awareness, external and internal, that's consciousness in action.
Next up is the representation of knowledge. This domain has 2 very distinct aspects. First, there's the conceptual representation in the mind, like how you personally symbolize an idea, which, by the way, can be vastly different from how the person sitting right next to you does. But second, there's the physical way our neurological web entraps and stores that actual information in the brain. And here's the cool part. Even though our individual conceptualizations differ, our neurological webs hold experiences in similar enough structures that we can communicate and actually function together in society.
Finally, let's move to Section 5, Domains 9 through 12, Complex Thought, Higher Processing, Language, and AI.
We've grouped these final 4 domains together because they represent the absolute highest levels of mental abstraction, as well as the most future-facing topics in cognitive science today. Let's walk through them. We've got language, developmental psychology, thinking and concept formation, and finally human and artificial intelligence. It is so vital to recognize that language is a totally unique kind of abstraction shared by all human societies. It's our main tool for acquiring and expressing knowledge, and it literally influences our perception of reality itself. Meanwhile, developmental psychology tracks how these incredible cognitive structures mature from when we are children all the way into adulthood.
So, the crucial point here is captured beautifully in this quote from our source text. Thinking is the crown jewel of cognition. It is the process by which a new mental representation is formed through the transformation of information. If you want a definitive, highly testable conceptualization of what thinking actually means in a rigid scientific context, write this quote down right now. It's all about transforming what you already know into something entirely new.
And that brings us to the ultimate application of thinking: intelligence. Human intelligence encompasses the ability to acquire, recall, and use knowledge. It's the ability to follow instructions and behave according to rules. What's completely fascinating is that our understanding of human information processing has directly fueled the computer science field of artificial intelligence. To design programs that can actually think, computer scientists first had to learn how we process information. All of this builds to our final thought. You see, cognitive psychology isn't just about understanding the past or the present, it's actively shaping our future. As we map out these 12 domains and perfect our research methods, we're left with a massive, genuinely provocative question that cognitive scientists are wrestling with today. Can a perfect robot truly simulate human behavior? Can a completely artificial system ever perfectly mirror the messy, complex, highly nuanced reality of human cognition? I'll leave you to ponder that as you review your notes tonight. Good luck on your exam, guys, and keep asking the big questions.